Hey guys, and welcome back to SteamWorks. So recently we were talking about feed pumps for our steam systems, and today we're going to take a look at some factors that affect these feed pumps for better or for worse. So as previously discussed with regards to pump selection, feed pumps require careful consideration to ensure that the pump not only can overcome the boiler's pressure as well as maintain the flow requirements, it also must meet specific net positive suction head requirements. Wait, say what? So first, let's talk about why NPSH, or net positive suction head, even matters in a pump. Simply put, it's cavitation. Cavitation occurs when water at the suction end of the feed pump turns into vapor in a boiler feed water case caused by high temperatures. As water is entering the pump, it begins to spontaneously boil. Air bubbles rapidly form, and as the water passes from the suction side of the pump into the impeller, then on into the discharge side, the bubbles implode and essentially create a shock-like effect on the impeller of the pump. The hammering is often described as sounding like sand or gravel inside the pump's casing, when in reality it's simply the bubbles imploding and causing vibration and mechanical damage. As the cavitation of a pump continues, the failure of the impeller is inevitable. Additionally, this vibration can lead to other mechanical and alignment issues that will ultimately destroy the pump. An impeller damaged from cavitation will often have an eroded or pitted look and will usually be no good or damaged beyond the point of repair at this point. So how do we avoid cavitation? The short answer is to ensure that our net positive suction head actual is greater than our net positive suction head required. In understanding these two terms, first understand that net positive suction head, or NPSH, is the liquid pressure existing at the suction end of the pump. Our net positive suction head actual, or NPSHA figure, is defined by what the system is actually producing, hence the reason it is imperative to have a pressure gauge at our suction side of our pump. Now our NPSHR, or required, is defined from our pump curve and is in short the amount of suction head that the pump requires in order to operate efficiently based on the curve's projections. All that said, if a pump is showing signs of cavitation or vibration, these two values should be compared to ensure that the actual pressure is sufficient for the pump requirement for best performance. This is where our manufacturer's data for our pump, along with properly installed gauges, are critical. Now, oftentimes, systems with high rates of condensate return can result in excessive feed water temperatures, which leads to this phenomenon of cavitation. Again, this typically can be remedied by providing the best possible NPSH to the pump to maintain as high of a pressure as possible, and the feed tank should be located well above the boiler whenever possible. Some boiler feed applications may see where it is necessary to utilize what's called a low NPSH pump. These specially designed multi-stage centrifugal pumps are engineered with an oversized first stage impeller and chamber that is essentially better suited for handling this high temperature feed water for many boiler applications. The design makes it better suited for the higher stresses that some systems may see due to poor suction pressure and near boiling liquid temperature. So boiler feed pumping is a subject with a lot of variables and a lot of depth. Boilers have to have water to perform safely and efficiently, and it is of utmost importance to always consult the manufacturer's recommendations on selecting these feed systems and to have a properly engineered system for maximum safety, efficiency, and reliability. All right guys, there you have it. I hope you liked this video, and if you did, be sure and hit that thumbs up button. Make sure and subscribe to our channel, and also I want to mention Steam School coming up September 1st and 2nd. We're already booking classes. You can get in touch with me at this number right here. And other than that, we'll see you next week for another video.